Hey guys, welcome to the shop. Welcome to part 2 of the gear pump rebuild. I've definitely enjoyed this little job so far, and if you didn't watch part 1, a lot of feedback on that. People seem to like it, but not as many people watched it as I figured would. So go check out part 1 if you didn't watch it. I'll try to put a link up here, so all this will make sense to you. But it's been a really good job so far. Everything has worked out really well. You'll see, other than one important detail. You'll find out. So, without further ado, let's get started. Alright, so now it's time to grind the gears on the surface grinder. But first I have to get this shaft out of this gear. It's keyed in, so let's press this shaft out of here and then go over to the surface grinder, grind these both as a matching set, and then fit them to the case. Hopefully all this works out. Hope that comes out easy. Oh, there it goes. Okay, not bad. Here we go. So gears are off the grinder. I just want to check them to make sure that they're both the same height and that I didn't get the tops and bottoms out of parallel. So let's get set up here and give them a check. And then we need to deburr these sharp edges. I don't want those wiping my oil off as they rotate in the case. Alright, so let's bring this in and zero it. And let's see, let's do one at a time. So we're 0, 0, man, it's not even moving. So that is good. Alright, let's check this one. 0. And not even moving. So that's good. These are exactly the same height, and from one side to the other, they're parallel. top is done. And the base is done, so we got to press our pins in. Gears are pretty much done. I want to talk about those a little more and see if there is another way to maybe tighten them up if what we do doesn't work. So we'll try the gears as is for now, but if it doesn't work, I've got another potential fix up my sleeve maybe. Alright, so if you had a bunch of these to press in, of course I've only got one, you know, that spacer is the distance I want this shaft to stick out of here, so it should be good. Press it in, and should be good to go, I think. Should be it. Alright, so there is our pump together. I'm going to be using, because I've used the top as a reference and the bottom, which are parallel together, I want to run over this real quick and just show you how close they are. So it's 0. We've got some corrosion here, so we'll drop off 0.6 or so, back to 0. Yeah, so it's basically really, really, really close. So that's why I've been using the top and the bottom. And now we need to check to see how much we need to take off the top of this in order to get our fit correct with our gears. So let me get set up and we'll measure this, then we'll take this case to the grinder. Alright, so we need to figure out what we need to do to set our clearance between the top of the gears and the top of the case. But first we got to find out where we're at. So we're going to be using this depth mic, same one we used to check the wear in the top of the case. This is made by the Tubular Micrometer Company. It's the long-footed version. I believe that's 3-inch version. And we'll check 0 on the plate. And it is very, very close. So we'll call that good. Now I'm going to check across this surface and the other, down to the gear, and see where we're at. Let me get you a little closer on this. Okay, so we start at 0. So we are 25, 30, 35, and almost 40. Maybe maybe a couple tenths below 40 thousandths. This gear face below the top of the case here. Now let's check. This one should be exactly the same or very, very close. Start at 0, 25, 30, 35, and right on the money is the other one. And it should be, because the case is the same depth, the gears are the same height. So there you go. So we need to pull off less than 40 thousandths. Exact number I'm not for sure yet, but less than 40 off the top of this gear case. Alright, so while we're here, we might as well talk about another potential problem that we're not addressing at this moment, that regards to slippage. The whole reason why we're working on this pump is because we're trying to tighten it up. We've addressed the tops of the gears, the bottom of the case, and the top. But we haven't addressed the ends of the teeth and the case. You can see that this is a 25 thou feeler gauge, and it easily slides down in between, the outside of the gear tooth and the case there, which could, if it doesn't work, once I get this together, it'll be because of that clearance right there being excessive. I don't know what these numbers should be, but I'm just saying that, this pump sucks up garbage and then chews it in between the wall. It has a lot of long striations in the cast iron wall. These gears are hardened, but they've also got wear on them also. So potentially I could braze the ends of these up, but these are hardened and I really don't want to heat them up and make them get soft. I could, I even considered taking the cutter grinder. This is 9 teeth, indexing using a cut-off saw, cutting down each tooth, hammering in a strip of brass or copper, potentially Teflon, anything that will close that gap up. They don't have to touch anything, they just need to make that clearance less. So, I don't know, maybe I should have machined out the, well, no, I should not have machined out the case, because we can't gain anything here without making cammed bushings for these, which is not something I really want to get into. But anyway, just keep in mind that I am aware that this has issue out at the outer edges of the gear teeth, and I'm exploring options in my mind on how I will go about repairing that if needed. Alright, so the name of the game, as far as I know, with grinding is clean. Everything's got to be clean. Otherwise, clean, flat, as good as you can. Otherwise, just setting this on a piece of grinding grit could cause us some issues. So stone the chuck off. You'd be surprised how soft these are, and just dragging apart like your diamond nib over it can scratch it and raise up a spot. So clean it off really good. Then our housing that we're going to be putting on there. Same with it. Feels good to me. Check the part. I've already dressed the wheel. I need to set up my end stops for my travel. I'm going to let this grinder's automatic. I'll let it do the work. And we'll take off, half of what I want to take off, check, and go from there. So here's how I touch off, or not necessarily touch off. I don't find it very easy just to lower the work head down till you see sparks. It just takes me forever, and a lot of times end up going too far. So this is just a scrap piece of feeler gauge, 3 thousandths thick. Just lay that on there. Bring it down, wiggle it back and forth until I feel some resistance. Then I know at least I'm within that close, or very close to this measurement, before I even turn the wheel on. Just safer for me. just hard to tell by eye. So there we go. I mean, that's a good place to start. Alright, so hopefully you can see this. You know, we're grinding pretty much everywhere, but right in this area, the darker area, and right here. That's where all the corrosion was on this face. Now, there was no gasket between this and the top plate, so, you know, it could be potentially sucking air in these areas. So it's good that we're cleaning this up. Alright, so I've stopped everything. Just getting started grinding, and I need to get my depth mic. I can't, you know, every time stop that I check my measurements, stop and clean out that case. So I want to measure it from the outside. I'll show you, but it's nice to have one of these depth mics with the extensions so you can measure more than an inch. You know, most of the time you'll use the 0 to 1 inch, but sometimes you need the longer ones, and in this case I do, and I'll show you why. So let's go over the grinder. I'll show you where I'm at and what I'm doing. Alright, so I've stopped. You know, this is full of coolant. Cleaned it all out, and I can't do this every time because it takes so much time. So I want to be able to reference off the side of the case here to the mag chuck. So I'm just being a little maybe extra cautious, checking to make sure I got that what I've taken off here so far matches with my dial down here. 25, 30, 35, and it does. So that's why I got out the other depth mic with the longer anvil, so I know what I've pulled off, and I can measure off the side of the case, which is much easier to wipe off, you know, with this full of coolant, and wipe off the mag chuck and check in this manner. That way I don't want to take off too much. Not that that would be the end of the world, but this is, it's easier just to do it to get the amount off you want the first time. So that's what I'm doing. So I'll bring you back when I'm done. Watching somebody grind is just a little more exciting than watching paint dry. Alright, so I'm shooting for 5 thousandths of clearance between the top of the case and the top of the gear. Let me get this cleaned up. We'll go to the surface plate and we'll see how it did. Alright, so let's first check and see how parallel we kept the case. How parallel the top is with the bottom. Get you in on that indicator. Alright, starting our way around. Looking good so far. It's a 10th. Man, that's good. I'm actually surprised that the grinder got this big of a surface, as flat as that, or as parallel, we'll say that. So that's good, you know, within a 10th or 2. Now let's check and see if we hit our numbers on the gear. Alright. We wanted 5 thou. And check it across. get you in on it. Zero. 5.5. So we missed it by a half thou, which I'm okay with that. Yep, half thou. So I'm fine with that. That's good. I don't know if I could have got it much better than that. So that's good. Here's another decent way to check 5 6/1000 crusty old feeler gauges. I really need to get a good set. Not that these are bad, but they just don't look good. So there's 5, and then 6. So, like I said, 5.5 thou. You know, I'm not sure that's what it should be. That's what it is. So there you go. Another way to check. Just a good known flat parallel. Alright, so I'm working on the bypass, or it's a bypass, or pressure relief valve. Just a brass plunger that runs into a bore in there that's tied into the outlet circuit and closes it up. If the pressure gets too high, or you close the outlet valve, the one that you turn off and on for the coolant, the high pressure forces this piston back and allows the cutting fluid to go in and then just dump right back out into the foot of the machine. This thing's only capable of producing pressure that this little spring will allow, or else it just forces it off the seat and you bypass. This spring was in it, and it's about rusted in two in a couple places, and it's definitely a weak spring. So I'm going to upgrade a little bit, a little heavier spring, just to maybe increase our outlet pressure just a little to keep this on the seat, maybe a little harder. So, you have to have a bypass on a pump like this. Let's just assume that all the clearances were extremely tight on this. It would be capable of producing extremely high pressures. They use pumps like this in hydraulics and stuff, so definitely needs a bypass. So that's what I'm doing. Let's cut the spring to length. I'm going to be using one of my favorites of all time is the non-reinforced little Dremel cutoff wheels. They're great, but they break if you look at them wrong. But there's a squirrel on the roof. Let's cut this to length and get it in here and get this thing together. All I wanted to do, heat that enough to collapse that last coil, and then I'll grind that flat just on the belt grinder. Give it a good flat surface. Alright, so check out this awesome piece of Euro mail. This was sent to me by Brett Smith. It's a 20-gallon parts washer. He went to Amazon, bought this, and had it shipped to me. How nice is that? You know, I just had mentioned that I needed a parts washer under my breath, just to Elizabeth, that, you know, when we were cleaning the parts for our arbor press, the smaller stuff, a parts washer makes everything so much easier. I've used these in almost every shop that I've ever worked in. It contains the mess. You do parts cleaning in one area, and that's it. It's got a lid, you know, it's just nice. Better than walking around with tubs laying around with half-clean parts in them, you know, with mess flipped everywhere. So thank you, Brett. I definitely appreciate it. He even bought me the brush attachment, so solvent runs through the brush handle and to the end, so that makes things nice. 20 gallon, I haven't got the solvent yet, but I haven't had time to research where to get it, how much it is, you know, what to use, so that's all coming. But yeah, check that out, that's nice. So, you know, thank you. And thank you to anybody who sent anything into the channel. You know, this kind of stuff definitely, as you can imagine, makes life easier. So check out how clean that is. I definitely don't expect it to stay like that very long. You know, but until I get the solvent for this thing, I'm going to still use it to, you know, contain my mess, cleaning up all the little parts that go onto the pump, and then as soon as I'm done with these, I can bolt it all together and maybe have time to get it installed. I'm not for sure. You know, we'll see. But here's the pickup tube. It's in pretty poor shape. This is cast aluminum holding a brass screen. I don't think it has any holes in it. I'm going to check it. It needs to be sealed in between here and here, or else, like one of the commenters said, it's like trying to drink fluid through a straw with a hole in it. It just doesn't work. So as long as this is sealed, I'm good with that. So we'll get all this stuff cleaned up and get that thing back together. All right, so that takes a number 5 tapered pin, and that one is in horrible shape. But that's all we got. I don't have a replacement. So there we go. That'll work. I mean, all it's got to do is stay on there, really. All right. I think that's it, other than the pickup. So I'm going to stick that on there. Thing in here. I'm not going to prime this or anything. I'm just going to see if it'll pick up oil on its own. I think that's, you know, the right way to do it. At least at first, you know, if I have to put a little oil in it, we'll see. But for now, I'm just going to see if it'll do it like it should, and that's on its own. Hopefully this video doesn't have a 3-part. Alright, so it's been quite a bit of work so far. It's not been that bad, but, you know, grinding all that stuff, fitting it, was, you know, a little bit labor intensive for a coolant pump. But I'm doing it because I like to do it. Hopefully this thing has some love for me and will work dry. I just want this thing to pick up oil. It's never going to be completely dry like it is right now. I just put a few drops on the bearings and stuff. But we'll see. Will it pick up oil dry? Let's see. Let me turn it on. I'll actually be surprised if it does, because it has a lot of clearance in between the ends of the teeth and the housing, which is not good. Okay. On. That'll work. And no, it doesn't work. Can't say that I'm surprised, really. Looks like there's going to be a part 3. Let me pour some oil in this thing, you know, see how it works differently from before, and then give it a minute and see if it'll pick it back up wet. It's a bummer, but you know, that's the way it goes. Alright, so I primed it and tried it, and it really is 100 times better than it was. I mean, it's got a lot of flow now. I need to take this nozzle off to get a true comparison. Alright, without the end on it. And definitely much more pressure than before. And quite a bit more volume. So what we did definitely helped. But it still could be better, I think. We'll see. If we let it sit, dry, let it run back, see if it'll pick it up on its own. That's pretty impressive though, really. Alright. Unfortunately, that did not work the way that I'd hoped that it would, but it did work the way that I expected that it would. We never addressed the wear on the ends of the gear teeth or on the insides of the pump and of the housing, which is somewhat substantial. And obviously enough to make this pump to where it won't pick up anything dry. So, other than make new gears, which is probably not going to happen, you know, I can build up the ends of the gear teeth only a small amount, but it may be enough to make the difference in between a working pump and a non-working pump. Once it picks up fluid, you know, it's good to go. So if I braze the ends of the gear teeth up, I'm just thinking out loud here, that could potentially be enough to make this pump to where it works, but that has issues in itself where it would probably ruin the heat treat on those gears, but in my limited use, I don't think that it would make much difference. What would you do if this was your pump? I don't need anybody to say, buy an electric pump. I know they sell these things. I just want to fix this one just because. Or maybe a wiper. Slot the ends of the gear teeth. There's a reason why I have not seen anybody ever do this before, because it probably wouldn't work, but you know, it's a thought. Slot the ends of the gear teeth, drive in a piece of copper, brass, Teflon, whatever. That doesn't have to touch anything. All it needs to do is close up that gap just a little. And I think we'll have a working pump. So, what do you think? What would you do? Leave me a message. That's it. So, click on my guide to subscribe. Big thanks to my viewers, patrons, and subscribers. I really appreciate you guys. If you'd like to support the channel, you can do that. Visit the links in the description of this video and all my videos. And I think that's it. So, thanks for watching, guys. And I'll see you next time.